Hi guys, so it's time to talk about percent yield, and I thought this was a really good problem because it makes you calculate both the theoretical yield and then calculate the percent yield. Sometimes you'll have already been given the theoretical yield and you just have to do the percent. But for honors guys, I thought that was too easy. So here's our problem. Ethanol is produced from the fermentation of sucrose in the presence of enzymes. Determine the theoretical and percent yields of ethanol if 684 grams of sucrose undergoes fermentation and 349 grams of ethanol is obtained. So let's think about what we're given. What is this number right here? Well, that is going to be our actual yield. That's how much we actually made right there. So, what is this other number they gave me? They gave me this, so many grams of sucrose. Well, that's going to be what I'm going to start with. And I'm going to use that number to determine my theoretical yield. And I usually put TH period Y for theoretical yield. And that's because I'm lazy. Okay, so we're going to first have to figure out our theoretical yield. We have our actual yield that will let us do as a second point our percent yield. And I often will write that as percent Y, percent yield. So let's do our first part, theoretical yield. So we are going to start with 684 grams of C12 H22O11. We're going to need a couple of masses. We're going to have to go from ethanol to ethanol as our final product, and we need the molar mass of sucrose. So how would we do that? Okay, so I think you guys know how to do the molar mass of sucrose. I just went and looked it up on the internet, and it told me that sucrose has a molar mass of 342.30 grams for C12 C12H22O11 for 1 mole of C12H22O11. And then for every, and this equation is balanced, so I'm going to say for 1 mole of C12H22O11, there are 4 moles of C2H5OH. We just did a problem with ethanol, and so if you remember from that, or you can figure it out, for every 1 mole of C2H5OH, there are 46.068 grams C2H5OH. Now I've got everything in place to do my calculation. Where's my calculator? There it is. So let's start our calculation. You don't have to clear this, but I just wanted to make it easy. So we're going to start with 684 grams. We're going to divide by 342.30. We're going to multiply that by 4, and we're going to multiply that by 46.068 equals. Now, I'm going to estimate whether I think that answer is reasonable. I start with almost 700. I divide it in roughly half. Then I multiply it by 4. And then I multiply it by 46. And I think that's looking pretty reasonable to me. So 368.2209. So let's go ahead and write that down. We get 368.2209 grams of C2H5OH. How many significant digits do I have here? Well, I have 3, so I'll have 3 in my answer. So that's going to be 368 grams of ethanol, C2H5OH. There's the first answer, but that's not the only answer I need. The other answer is going to be theoretical yield, or percent yield. And so this is the theoretical yield. This is my actual yield, highlighted in yellow. And I need my actual yield divided by my theoretical yield times 100. So it's going to be 349 grams divided by 368 grams times 100 equals. So let's get our calculator. And we have oh, I wrote that wrong. You guys should have told me. Oh well. Let me get out my eraser. Here's my drawing tools. I need my eraser. Let's rewrite that. Let's see if I can write it the right way this way. So we're going to have 349 grams. Whew, that looks better. I was going to have a really bad yield, a really high yield over 100% the other way, and that wouldn't work. So 349 divided by 368 times 100 equals. And this problem I got 94.836. So 94.836%. And we have 3 significant digits, so I can only have 3 here, so it's going to be 94.8%. There we go. We did our percent yield, we did our theoretical yield, starting with theoretical yield and then doing our percent yield. Hope that's helpful. We only have one type of video left. That will be limiting reactant. Unfortunately, that's the longest one to do, but I do have a foolproof method and I think you'll like it. Okay, talk to you in a bit.